Chapter 14, Environmental Health and Toxicology. The case study is an important one you might see on your AP test, and that is about endocrine disruptors on alligators. And later in the book they talk about endocrine disruptors on frogs. An endocrine disruptor is something that messes up the hormonal system. And there's a lot of chemicals in our environment that we will discuss that do this sort of thing. So turning the page, there's nothing really to sticky note, but do make a note of the case study to review. Page 402 goes on to talk about different kinds of hazards, and what you really need to know is these terms here on page 403. We have infectious disease. Another term for infectious is communicable disease. It's also transmissible disease. These are all synonyms of each other, and the AP test may use any three of those words to talk about a disease that can be caught from another person. A pathogen is, well, we call it a germ, but it's something that causes disease. Here's something that's not in your book, but it may be on your AP test. A vector is a carrier of a pathogen. For example, rodents and mosquitoes. Now, mosquito doesn't make you sick, but mosquitoes can carry things like malaria or West Nile virus. Malaria is a small protozoa. West Nile virus is a virus. And so the mosquitoes, we call them vectors. The same thing with rats and mice. Now, you don't want rats and mice in your house or in your kitchens because they carry the diseases that hurt you. The Black Plague is an example of a disease that was carried by the fleas that were on the rats. So the vectors were the rats and the fleas that carried the bubonic plague, which was a bacteria. Turning the page. On page 404, you need to know this chart that tells you the leading causes of death. The first chart here is the leading causes of death in the world. And you can see that infectious disease still is the second leading cause of death worldwide. And of the infectious diseases, these are the ones that kill the most people. First is respiratory diseases like influenza, pneumonia, then AIDS, then diarrheal diseases like cholera and cryptosporidium, tuberculosis, malaria, and then other childhood diseases. Now, in the United States, we don't think so much about infectious diseases because we really, for the most part, have them under control. Now, yes, there are still thousands of people who die each year of the flu or AIDS or a tiny bit from tuberculosis in the United States and other developed countries like Europe. But for the most part, when somebody gets an infectious disease, they can go to the doctor, get antibiotics, antivirals, and most people do not die from an infectious disease in the U.S. But in other parts of the world, you still have a lot of people. In fact, in other parts of the world, it's the number one cause of death. So let's go ahead and look at our sticky note here again. And so you need to know this chart and this chart. And you also need to know in the world, the number one cause of death is cardiovascular disease. In developing countries, poor countries, the number one cause of death is infectious disease. Sorry, I smudged that, that's an I. So in the U.S. and in the world, heart disease is going to kill you. That's the leading cause of death. But in a developing country, some sort of infectious disease is most likely to kill you. Here's something to add on to the book. It's not in your book, but it's important to know. Increased air travel around the world has increased the number and types of infectious disease. Because if there's an outbreak in one part of the world, somebody can catch it, and before they come down with symptoms, they can hop on a plane, and they can come to a different country and spread the virus or bacteria or something around before it's ever even noticed. All right, on the next page, we have a couple of toxins you need to know about. The first one is radon, which is a toxic radioactive gas. It comes through the bedrock in a home, and it's found in the basements because basements are usually dug into the bedrock. Radon causes lung cancer, and it is a type of indoor air pollution. The other toxin that's mentioned on this page is lead. Now, lead is a heavy metal. It causes brain kidney damage. It's found in old paint, lead pipes, and old gasoline. Now, the gasoline that we currently buy in the U.S. is unleaded gasoline. So it's just your older gasolines in other countries that still allow lead that you're going to have that in the gasoline. But the current gasoline that we buy for our cars right now in the U.S. does not have lead. It's called unleaded. How do people get lead poisoning? Well, some of the more common ways is children can ingest peeling paint in older houses and become poisoned. Now, it's an older paint, so if you live in an older house, I'm talking a house built before like 1970-ish. So most of you live in houses that were built after, 1970, around that time. So in Santa Clarita, we don't have a whole lot of problem with lead-based paint, but when people buy older houses and they repaint or the paint peels off the windowsills or something like that, that's where children can get infested. They can ingest it, and it can cause learning difficulties and damage. Lead poisoning more often happens to poorer children because poorer children tend to live in older houses where the maintenance is not kept up, where there would be more peeling paint. Also on this page, take a note of West Nile virus here and the spread of the West Nile virus. It's a newer type of virus, and we will go through a lot of toxins on a chart that you will need to fill in later on, and we will talk about West Nile at that time. And also we'll review radon and lead. Regarding all of this detail found about each of these toxins, yes, you do need to know all of the detail. Everything that we list here is important to memorize. All right, next page. On page 406, make sure you know these terms: asbestos, asbestosis, and mesothelioma. So asbestos is an insulator that was used a long time ago. We no longer build homes with asbestos, but some older buildings and homes and schools even have asbestos in them as insulation. Now, asbestos doesn't cause problems unless it becomes loosened, like from an earthquake or through renovations, and then they have to do special things to the building to eliminate the asbestos without people becoming sick. Asbestosis is a lung disease caused by asbestos, and then this is a specific kind of lung cancer caused by asbestos. Now, some of you, if you've watched daytime TV, may have seen a lawyer that advertises, if you've been affected by mesothelioma, which is a lung cancer caused by asbestos, then call and you can get some money. Mesothelioma is not in your book, but it was actually on the AP test about 3 years ago. And my students knew the answer because of that commercial by that lawyer. All right, on the next page, make sure you know about different kinds of toxins. And then also, there's natural toxins in the world. This is page 407. Poison ivy and oak. Radon's natural. This is not man-made. Oil that oozes from the ground. These are all natural toxins. And so it's good to remember that not everything that's a toxin is man-made or synthetic or comes from a chemical factory. There's a lot of natural toxins. All right, turn the page. And here we have a child being sprayed with DDT. And back then we didn't recognize how dangerous it was to spray a person with pesticide. It seems obvious now, but back then apparently it wasn't that obvious. On page 409, make sure you know about Rachel Carson, who wrote a book called Silent Spring. And in this book, she describes the effect of DDT, pesticide, on ecosystems. Now, DDT is currently banned because of this book where she talks about the evidence of the horrific effects on ecosystems. But it's kind of ironic because we still make DDT, but we sell it overseas in countries that don't ban it. And that's kind of irony to me. Now, DDT is still the best pesticide against mosquitoes and malaria, which in essence is a greater health risk than DDT exposure. In Africa, for example, 1 million people or more die every year from malaria. And so a lot of African countries will still spray DDT because they want to protect their people from dying from malaria, because DDT still kills mosquitoes. And so you have this risk analysis kind of thing. Yes, DDT is bad, and it's bad for the environment, it's bad for people, but a higher risk is the risk of malaria. And this is kind of a tricky thing. We talk about risk analysis later in this chapter, and when you're talking about the risk of certain chemicals, you have to realize that sometimes not to use a chemical poses a greater health risk. In the United States, we ban DDT because we don't have a problem with mosquitoes and malaria. And so we can use other kinds of pesticides that are not as toxic and protect our ecosystems and endangered species. You need to know what thalidomide is. It was a drug in the 1960s to relieve nausea, morning sickness, we call it, during pregnancy, and it caused limb deformalities, and you can see the tennis player here playing without arms. Make sure you know these terms here. Oh, these are my little notes to myself. You don't have to copy those, but copy what's in purple. Carcinogen is a cancer-causing substance. Mutagen mutates DNA in the body, and a teratogen causes birth defects. Make sure you know those terms. All right, on the next page. More terms to know. Make sure you know the term allergen, neurotoxin, and endocrine disruptors. And make sure you know this chart too. Let's talk about this chart. Here's a little note that you need to know. I just added this last year. In Japan, there was a company several decades ago that dumped a bunch of mercury into a bay. The bay and the area in Japan was called Minamata, and they dumped mercury. And so it's right here in this paragraph, between the 1930s and 1960s, a Japanese company dumped mercury into this bay, and it caused huge amounts of kidney failure and mental retardation and other kinds of problems. Make sure you know about that on this page. All right, an endocrine disruptor. All right, let's talk about that. So in your body, when you come across a carcinogen or an allergen or neurotoxin or something like that, the body will recognize that as foreign and attack it with the immune system. But the problem with endocrine disruptors is that endocrine disruptors are in such tiny amounts that they fool the body. The body actually thinks they're hormones. They mimic hormones in the body, and then the body doesn't create an immune response. Now, if these substances were in higher amounts, the body would recognize them as toxin and send an immune response, but it doesn't because they're in tiny amounts. So, for example, here's a cell. And inside the cell you have hormone receptors, and here's a hormone that comes in and it fits right into this receptor and it causes the cell to do something. For example, in your intestines you have these cells and you have thyroid hormone that tells you how fast to digest food. So the thyroid hormone will come here and it will tell this cell how fast to process what you eat. Or, for example, in the testes, you have these receptors for testosterone, and it tells the testes to produce sperm or the ovaries to produce egg or something like that. Well, what happens is that there are certain chemicals in our environment, in our plastics that we eat out of, in our pillows that we lay our heads on, and they can get in the body and they fit right into the same receptor on the same cell. And so they mess up our hormonal system. And this is really new science.